Why, hello there. Welcome to another live stream. Let's tone that music down a little bit. Let's see. My audio meters are, registering. That's good. I think this needs to move a little bit over here. Cool. How are you guys doing? And I'm thirsty, so it's either, dinged up lemon or, Coke Zero Cherry. But I'm going for lemon. You don't get to choose. Too bad. Yeah, that was accidental great timing there, Emil. We'll get to the cherry later. Cheers. What are you guys drinking? Let's see. Bitrate is looking good. Audio is looking good. I think we're ready for this. Well, it would still be tonight. So, hey. Cofola. I've never heard of Cofola. Plain old Coke Zero. What? YouTube is not receiving enough video to maintain smooth streaming. But I'm at 16 megabits like I'm always at. Oh, DJS says, good evening, sir. A mug of tea myself. Thank you for the £2. That's very nice. I enjoy a good cup of tea now and then. Not often, but sometimes it's like, I want a good cup of tea. Yeah, I get that. Plain old water. Yeah, that's fine too. Although I don't drink plain old water a lot myself. I like the stuff. So to answer the question, are thin pigtails a problem? Is yes. Stream over, good night all. Well, I don't think so, Johnny. I don't believe there will be a problem. But you think something else than I do, so the only way to find out is to test it. So let's do that. Oh, Den van Santen, you got the 24-volt cob LED strip from my video. Can I get it to turn on? Do I need some special settings for it? I use a generic ESP32. Not that I know of. I tested with a Dig Uno or Dig Quad. And a Dig Octa, I think. I'm not sure anymore. But two of those at least. And they just worked fine. Maybe use a level shifter, something like that. GGS says, I'm English. Tea is pretty much all I drink. Yeah. Time to blow up stuff in the name of YouTube content. Electro boom style. Actually, I don't think the first part will be that, because we'll be testing the wires. I don't expect any smoke. And besides, I'm using silicone wire, so, it took a lot to get silicone wire to smoke last time. But there will be a second part, which I didn't announce, where we'll be testing some buck and or boost converters. And we might be driving those over the limits. We'll see. It depends on how long everything takes. What have I killed this week? Nothing, actually. The secret we revived last time has been going strong. Still working. It's still looking horrible, but hey. You forgot to order silicone cable. I have an affiliate link on my equipment page. If you're looking for it. Secret smoke. Oh, you were going to ask about buck and boost converters? Okay. Yeah, but Dan van Santen, to get back to your cob LED strip, I don't know. Are you trying to put the data into the strip on the correct side? Other than that, I have tested 5 or 6 of them. 0 issues. So, I mean, there's even official WS2811 chips on there, so. Yeah, lost the signal. That's what YouTube's telling me. Stream health. YouTube is not receiving enough data. You're not receiving enough data. Well, yes, that's correct. But you ordered silicone USB cables. Do you have a link to that? I'm a sucker for USB cables. I have so many USB cables. It's stupid. Yeah, you've been playing along with some nice hardware there, Emil. It's expensive, but hey. We are receiving enough data. Yeah, I'm just sending out 16 megabits and I've dropped zero frames. So, I don't know what the deal is. Hey there, Mr. Blue. Greetings from Antwerp. Hey there. Oh, YouTube now thinks I have an excellent connection. Is it time for an ad? Should we do a pre-stream ad? Oh, yeah, it's time for an ad. Okay. I've ignored YouTube 16,000 times now. It is time for an ad. I'm hitting the button now. Okay, I just inserted an ad. I don't know what's going to happen. It's ad time. It's finally ad time. Is anyone getting an ad? Yeah, got a link to those, Johnny? Stupid ads! Last time stream crashed. Uh-oh. I got premium. What ad? Nothing happened yet. Oh, no, more premium. I'm on premium too. Dr. Z's ad? Really? You got an ad for Dr. Z's? Ad blocker clicked in blocked lol. No ad. Paid for no ads. No ad. Everyone's having ad blockers. Oh no. YouTube's going down. Oh, you got premium? Okay, that's good. Premium, yeah. Oh, okay, that's a good one, Electronerd. You got spammed. Sorry, I won't push the button again. I just thought it was funny. What do I need you to? Why would you send me $100? I mean, that's okay, but you don't need to. Very anticlimactic. No ads here. Well, the ad button is already lit up again. So you can do an ad every minute, every other minute you're streaming, I guess. You got one of these. Let's have a look. Liquid silicone. Okay. Soft skin. Oh, they're in Type C. Cool. $2 meters max, huh? Oh, it's only USB-A to USB-C. Well, they got some funky colors there. That's funny. Well, check those out. Add to cart. Add it to cart. There we go. Wait, am I logged in here? No, I'm not. Stupid. Let's hit some buttons. Hold on. There we go. Okay. This mouse is malfunctioning. Sucks. Okay. Yeah, I think I might have gotten the idea there, Stephen Webster. Because we get this question a lot, like, how do I connect my 12 gauge cable to my LED strip? It's way too big. And, well, that's correct. You shouldn't. Have you ever joined the 24 volt ground before the buck converter with the 5 volt after the buck converter together? Does anything happen? Well, that's a very simple question. Is it a isolated buck converter or a non-isolated buck converter? Most buck converters are non-isolated. That means they have shared ground. If they are an isolated buck converter, they don't have shared ground. So most buck converters already have shared ground, so before and after. Yeah. So, yeah. Aw, sorry, Philip. Good evening, Rob de Graaf. ABP crashes out YouTube. I don't even know what that is. So we're still in 5 minutes. I've actually set up the auxiliary cam. Let's take a look here. See that? Oh, we got a third cam today. Ooh. So we can have a look at those figures too. If that question's for me, Draadstaal, no, I have not yet. I should, but there's always too much stuff going on. I mean, yeah. You only work 2 days a week now, Johnny. That's nice. Wait, why is the intro music starting again? That's not good. Oh, uh-oh. I must have forgotten to enable the music here. I did, huh? There's also no chat? Oh, no. Okay. Sorry, it's starting again. Wait, I can skip numbers, can't I? Yeah. There we go. Let's skip a few numbers. There. It's like nothing. It never happened. Oh, yeah. I hope you get better soon. Or hope you get better soon there, Adam. You like the no signal song? Yeah, it's funny during a stream. 50 empty 4 is out. How is the music volume? I can't tell on my own headphones. I can only tell by the meters, but I hope it's okay. The volume is okay. 2 days work is still 48 hours. Nice. So, I guess the real secret today is I have things strung up here. That's because they're doing a long-term test. I have auto ducking on the music from the microphone, but it shouldn't become too loud when I'm not talking. That's the problem. So, yeah. Oh, you're visiting the Netherlands in May. Welcome, Jordan. But yeah, there's a long-term test going on here. Maybe I'll share a secret about that. Maybe. We'll see. Yeah, they're pucks. They're, do I have some here? No. Can't really get some. Here's some test pucks I got from AliExpress. So I'm going to sell Christmas lights. No. Well, we might get into selling LEDs at some point, but That's not what this test is about. You'll have to hang out until the end of the stream to find the secret test. Right, it's 14. I'm done waiting. Let's talk about our subject today, because I want to, start building it. Oh, Christian Kvisk asks, when will the Power 5 be in stock again? Currently, we're out of stock of everything. Dig Unos, Dig Quads, Dig Octas, Data Boosters, ESP32s. I don't know, it's all gone. We do have some Dig to Go's, I believe, but that's it. And we kind of ran out at an unfortunate moment. Normally we try to run out like somewhat past Chinese New Year so that we can have new stock available and, not really be out of stock. But now we ran out like a week before Chinese New Year. So then it's like 2 or 3 weeks of Chinese New Year. And then the whole of China's ramping up. So production, instead of taking 3 weeks or so, takes 5 weeks. And you're waiting on components and other services and things like that. So we're out. We're out of everything, and it's taking a long time, and I'm really anxious about that because but we're not going anywhere. We're reproducing everything, or we're producing everything, and I'm hoping the Dig Uno and Dig Quad will be somewhat like in 2 weeks or so. Will be in stock again. And Dig Octa will follow 2 or 3 weeks, or no, well, yeah, 2 weeks after that. And then everything should be at normal levels again. We'll be sending big shipments to Dr. Z's, etc., etc. So, make sure to subscribe to the mailing list for Dr. Z's and on the Worldwide store. You can also sign up for an email notification. And then you'll be first to know when it's in stock. I'll also announce it on Discord. But yeah, we ran out completely because of the late year rush, basically. And that's good. I mean, business-wise, we sold a lot, so that's good. But it's not good to be without. So yeah. So it's coming. I have to wait a few more weeks, and then it'll be there. Right. So let's go here. And let's disable this one for now. There we go. So today what we're going to do is if you calculate your LED setup, right? And let's do that real quick. Let's do that. I need to prepare this scene a little bit. One moment, please. Let's turn this off. Oh God, I can't see. Okay, and then this goes here. No, don't do that. No, don't do that. And then I need to do this one. There. If we take a look at a voltage drop calculator, and we say, okay, I want how many meters of cable do you think this is? I don't know, 5 meters. Let's say it's 5 meters, right? I want 5 meters of cable, and we do DC 5 volt, and we need 8 amps. If we use 18 gauge, that will give us 33% drop. That's way too much. Let's go to 16 gauge. That gives us 21% drop. That's too much. Let's go to 14 gauge. That will give us 13% drop. Still too much. So let's go to 12. That will give us 8.3% drop, or 0.41 volts, right? Oh, David Dupre Jr., will Web Installer be updated for quad soon? Yes, we'll get working on that. For now, you can take the Dig Uno variant and just add the 2 extra data channels yourself, and that's it. It's basically the difference in the configuration there. But yeah, Philip will get on that. I kind of dumped that project in Philip's lap, and he made it great. He certainly got a lot further with it than I did. But it still needs some tweaking here and there to get the right versions up. But yeah. So looking at cable, if we want 8 amps, which is a middle injection, right? So Generally let me show you that real quick. We did some tests on a previous live stream. If you go to digitally addressable LEDs, and then we go to how much can a single injection point handle, we had a live stream about that, and we could see that a single injection point basically handles about 4 amps max. And if you do a front plus end, or you do a middle injection, it can handle about 8 amps. So the 8 amp figure I used here isn't grabbed out of the air. If you're running 5 volt WS2812B with 300 LEDs per 5 meter or 60 LEDs a meter, that is a expectable amount of current you could draw from that point. So that's 5 meters away with 8 amps. And, well, we just saw we need 12 gauge. Well, what? Philip is on strike. What? Oh no, that's not good. Anyway, this is about 5 meters of 12 gauge. And then we also, but the problem with 12 gauge is we can't really solder that to the LED strip because, well, it's way too thick. You know, the wires themselves are the same size as the LED strip itself. So we can't really solder this on there. So the idea is then we take a bit of, what is this? 20 gauge? I think so. Yes, this is 20 gauge, which is, as you can see, come on, yeah. As you can see, this is, oh, yeah, there. This is a lot thinner than this guy. But we need thick wire for the distance. But if it's a small distance, it's okay to use a bit of thinner wire. Or, well, that's the theory. So we're going to make 2 little pigtails. And we'll have a piece of thin wire, 5 meters of thick wire, and then, again, a piece of thin wire. And see if that influences the amount of current we can actually run through there, or is this going to create a horrible voltage drop, or is it fine to have like 10 centimeters of it and solder this to the LED strip instead of trying to solder this to the LED strip and ripping off the pads and, you know, that kind of stuff. Now I'm on a sympathy strike? What? What? What do you mean I don't want to hire you, Philip? I wanted to hire you, but, you know, you got a job immediately. And I probably can't pay you very well either. Well, we just calculated that we're going to have 0.41 volts of voltage drop. We'll see. No fuse? Well, in the worst case, this could be a fuse, but... Real men use 0 gauge. Well, we played with that in the last 2 live streams. I have some 0 gauge, but it'd be nuts to run it through there. And I don't really want to ruin that cable, because it's quite expensive. We need to start a fund for me to hire Philip. I'm game. Hey. Dutch Taurus will moderate for free LEDs. I don't really give out free LEDs. I give out free LED boards sometimes, but then I do expect you to test them. And they might malfunction. Thanks for the 24 volt buck converter videos. Best videos ever and helped me with my setup. Excellent there, 50MT4. Thank you for the $9.99. That's very much appreciated. Sure, I'll give Philip $1 from your super chat. That's fine. He certainly deserves it. Real men run 380 volts, 400 amps to their LED setup. Even I might not have enough LEDs for that there, Philip. Emil. Oh, 50 SAK for the Hire Philip Fund. Nice. You got $2 there, Philip. I'll allow that message. There. Okay, so while you guys are bantering, I do need to kind of get started. Because should we do a resistance measurement on it? Let's do a resistance measurement on this cable. See if that works. Let's turn everything on. Okay, let's turn on the multimeter and then get it on the screen. You ran a 3v3 to a 5mm LED without a resistor? Uh-oh. Let's wait for the scope to boot. There, oh, you can't see the scope. Well, you don't have to see the scope. Because we have the magic of... I don't know how it's called again. The program. No, the stupid start menu. Give me all the apps. The Easy DMM app. Yes, you can have administrator rights. I don't know why, but you can have it. There. And then we need to enable the... Oh, there it is. So, okay. So now you can see the multimeter just, over there. So let's disable that. And let's go to... I guess we'll go... Please exit remote. Oh, damn it. Okay. I want to... is it 2-wire resistance? No. Yeah, I guess it's 2-wire resistance, huh? Overload. Okay. Let's see if we hold the probes together, what we get. Okay, so if we hold the probes together, we get 0.05 ohm resistance. Okay. That's pretty good. So let's stick it in here. Okay. Let's stick it in there. There we go. And then stick this one in here. There. I'm afraid my multimeter might not be accurate enough. Oh, wait! Philip is here. Philip is donating to the Higher Philip Fund. I don't know how that works, Philip. But Mr. Blue says, startup for the Philip on Strike Fund. Oh, wait, you're like paying him to be on strike? I don't know about that. Anyway, so now we have 0.09 ohm resistance. So that's like, the complete cable here. Let's do the positive side too, I guess. Okay, and... Oh, it's unexpected, or expected, but... Oh, we got a little bit more resistance. Wait, what? What's going on? That's not right. Look at this. Okay, now I'm starting to doubt my setup. Look here. How does this work? Why? Why is this software so horrible? This is like a $350 multimeter. How can this say 0.0009 or 0.09 and the screen says it says 0.10. What? How? Yeah, but it's the same thing. Rounding error where? Why is this software so stupidly bad? Oh, man. Oh. I can't even. I don't know. $600. Nope. Shingrish! Yes! It's just... Oh, man. I searched a long time for a multimeter I could use on stream like this. And it's been okay. It takes some hackery, but it's okay. It works. But this is just stupid. Okay. Well, for comparison's sake, that was about 5 meter of 12 gauge. Let's see what happens if we test resistance on this bunch here. I don't even know how long this is. Okay, I got an end here, and I got an end here. I need to strip it real quick. Oh, the magic of automatic wire strippers. It's just amazing. Okay, and let's see what it does here. Oh, okay, sure. So this is, I think, 20 meters, so not 5 meters. And it's 20 gauge instead of 12 gauge. But we're getting 0.71 resistance. So depending on which screen you're looking at, that is about 7 times as much as the 12 gauge. Of course, it's 4 times as long, so this is really not a scientific test. No, I don't have a Cat 5 tester, and also how would I get the wire in there? Hey there, Dave Odessa. Oh wow, you got some bad automatic strippers there, Emil. You should be able to do that with Cat 5 cable. Anyway, I'm thinking how I want to do this. I'm guessing I kind of want to first test the cable as is. So test it like this and see what voltage drop we get. And then we add the 2 little pigtails, so one in the front and one in the back, and then see if we get more or less voltage drop. Is that a good plan? I think that's a good plan. Well, this is a Knipex2, and this will do 0.03 millimeter square to 10 millimeter square, so I really like this one. This works fine. Does folded cable have more resistance than straight cable? Maybe a little bit. I don't know. Wago. I'm not sure this will go in a Wago. I was actually thinking of soldering it. But it's a good plan, because if I don't have to solder it, that will save a lot of time and we can do some other tests. Let's see if I can get it in one of these. Right? And then we can also measure resistance. Somewhat. I don't know of another way to test it than injecting data into the strip there. Then Ven something. Yeah, I didn't have any issues with it. And as I said, I have 7. 3 of that variant and then some other variants. Where are my scissors? Where are my scissors? I have a pair of scissors here, but not the scissors I'm looking for. I might have used them in the garage. I probably did. I need to get the scissors, because otherwise we're going to have ripped cable and, you know, it's already expensive enough. I will be right back. One moment, please. Where did my scissors go? I'll try it with the other scissors. Interesting, interesting. Nope, don't see them. How odd. Okay, so for this type of silicone wire, the best way I've found to separate the wires there is by cutting in between them, like so. And then you get a very clean separation, as you can see here, without it ripping and tearing and things like that. Okay, maybe a little bit more. There we go. That works fine. See that? No ripping, no tearing, nothing. Okay, I don't know if I'll be able to get this into this fake Wago, but we'll try. Let's make sure we strip off enough. It's almost the right length. Let's twist it a little bit. Hey, Andy's here. Nice. Ah, this actually fits into the Wago. Didn't expect that. Yeah, it's not... I need to strip more of it, but that's fine. There we go. Oh no. Okay. And also strip this side. Now this will of course also add resistance, but you know, we'll measure that. A proper made cable will split cleanly along if you pull the wires apart. Silicone is a bit more delicate than normal PVC wire. I've never had PVC wire rip on me, but silicone, well, for sure. Okay, so let's jam this in here. And then let's jam this in here. Okay, so it's not the prettiest. It's not the prettiest. But it's pretty good. As long as they're not touching, that's fine. And this is certainly a good connection. So now let's measure resistance with the added Wago clamp. So let's, just clamp my my sensing wire there. Okay. And where is the other side? It's over here. There. Oh wow. Okay. Oh yeah, it's a little bit higher. So the desktop says 0.10 and the software says 0.11. At least it's consistent. Red? You're not red here, Maiko. Yeah, I'm getting donations to hire Philip. So, adding the Wago seems to have added 0.01 resistance, right? So, let's do that little trick again. And add the Wago on the other side too. I need to get this cable out. This will be easier than I thought. We don't actually have to solder. That's a lot of shrink wrap, or how do you call that? Hook and loop tape. And later, once we do the actual load tests, we'll see if having it coiled up like this makes for a different resistance and unwinding it. That's a cool test too. So let's cut this gently. And I had stripped just a little too much, so let's do a little bit less. Let's get another fake Wago. Okay, and let's get these in here. I saw that, but it's okay. The small wires there, but Klittenband, yes, Velcro strap. That was what I was looking for. But the Velcro is a brand name, but I do like using Velcro. But the generic term for it is hook and loop tape, I believe. So let's try and get all the strands in on this one. Yeah, that's really difficult, but this one's at least flush. Okay, that's a good connection. And there we go. Okay, that's in nice and flush. So now we add our probe here. And we see 0.10. Wow, it's lower. We get a lower resistance than poking it directly into the cable. That's interesting. Huh. I didn't expect that. I'm not sure what's going on there, but maybe if I wiggle it a little bit. Yeah, if I wiggle it a little bit, it goes to 0.11. Okay. The meter also says 0.10. More contact surface. Well, not more than sticking it right in the middle of the copper. I can't imagine that. But it's okay. It's a decent measurement. So we know that the Wagos with no load add very little resistance. Barely any. Right? So we went from 0.09 on the display to 0.10. Let me disable my audio there. Because people are messaging me. Okay. Okay. So I think what's left now is to add little pigtail wires. So I'm thinking doing about this length. So that's a decent size pigtail. That's longer than you'd normally see like included on the LED strip. And let's do one for the other side too. There we go. Don't need that anymore. I have load tested these, Emil. They're fine. Tell it to the high voltage guy. 0.1 is nothing. Yeah, exactly. Okay, so let's get this stripped. And I'll have to make connectors on here for my power supply on one side and to go into the tester on the other side. And then we'll hit it with 8 amps of load. And yeah, see what happens. At least without load, there isn't a big difference. But maybe there is with load. Who knows? Let's get these twisted up a little bit. Oh, yeah, okay, I can split these. There we go. They should be about the same length. Yeah, that's about the same. Okay, that's good. Let's get my leads out of here. And let's test it with just the pigtails right now. And no load yet. So let's put that one in there. There we go. There. So now if we test the negative against the other negative, we see... Let's press it firmly together. 0.12. Okay, so that is a bit more resistance. To make sure that's not me holding the cable or something like that, let's get some more of these clips. And let's put them in the clips and measure it like that. Just to make sure there's no influence from me holding them or something like that. Okay. That's one side. Thermal camera ready. Yes, no problem there. Let's get this in here. Yeah, but once we apply load, we'll see higher resistances, or at least have it do more. Ow. Okay, and there. Okay, still 0.13. So we went from 0.09 to 0.10, 0.11-ish using just the Wagos, and now adding the little pigtails on both sides. Okay, we went to 0.12 to 0.13. So we can see a little bit of a difference there. We do actually see more resistance than we saw before. Of course, there's now multiple connection points, and every connection point you make will add resistance. Maybe if we soldered it and things like that, it'd be 0.11 or, not even show up. What? You're not mad at me anymore, Philip? Thank you very much. That's appreciated. All mods are ignoring the stream and just chat. That's what we do in a Discord server too, so Okay. So this is working fine. Now let's see what happens when we put load on it. Right? What kind of voltage drop are we going to see on the load? And will having the pigtails there or not make a difference? So let me think how I want to do this. Here's my load tester. Get that out of the way a little bit. Here's my load tester. And I'd have to finish up the cable to do that. No, let's unscrew these wires because these are 10 gauge, I think. Yeah, 10 gauge. But we don't need those right now. I have 2 thermal cameras, Dave Odessa, so we'll certainly be using those in a minute. Okay, let's get these cables out. What is a pigtail wire? Basically, it's when you have a thick wire and a little piece of a thin wire like this. And that's called a pigtail because, it's a little pigtaily thingy. So, these measurement tools use a 4-wire measurement scheme. So there's 2 posts that actually draw the current, and then 2 other posts which measure the voltage. So our first test is without the pigtail wires. So let's wire in this 12 gauge directly. I try to read now and then, see if I missed anything important. Maybe the pigtail wire will get hot, maybe not. So I always have to check on the back. And you have a V plus and a V minus. I guess I can show you. There. You have a V plus and a V minus, and an I plus and an I minus. Now the V plus is where the load should go. And the I minus and I is where the information or the voltage measurement is being done. Normally that's so you can test things with a 4-wire method. Now we don't really want to do that today. Okay, I need to open this up more. And let's jam these wires in there. They're a bit long. Oh my... Okay, this is too long. Yeah, okay, that's too long. Okay, but I don't want to put ferrules on there because I later want to be able to use the Wago. So I'm just going to cut it and then strip it more later on. But that's going to create a giant mess. So let's do that on a little piece of onderzetter. I actually got new cork mat thingies from IKEA, and they've been screwing people over. These are the ones from a few years ago. They're very different. So I can't recommend IKEA cork surfaces anymore, because for one, look at that. Look at that. They've become, well, significantly smaller. So it's the same thing, same product code, but it's actually smaller. And the surface, this is very flimsy and brittle, and it you know, I get dents in it, and it's not great. Well, the other ones I have from a few years back, they're nice and strong, and you know, I can't really bend them, and they're good. This is, it's just floppy mess. Not cool, IKEA. Not cool. No, these are from the IKEA. Like the same I bought a few years back. So I can't really recommend those anymore, which sucks. Okay, let's strip let's make it this much cable. That's a straight edge if I've ever seen one, not. And do the same over here. I don't know, but the old ones were really a lot better. So I think Johnny there told the IKEA headquarters, like, hey, they're all buying them now, we can screw them over. No, I don't think so. Okay, so let's screw in the bare wires here. Yep, you can see. Now I'll have to unscrew these in a minute, but it's okay. Okay, so in theory that's one side done. Not actually, but we'll revisit that in a minute. Let's remove the Wago from this side. They don't have cork in Russia? What? What? Why not? So the other side will be my Ruden RD6024 power supply here, and I need to edit this real quick. Nope, wrong button. Nope, still wrong button. There. Look at me being a professional live streamer, huh? Isn't that great? There. So now when we turn it on, we can see the screen. This side we need to finish with something else. We need some fork style terminals, and I prepared my little box here to dig them out, because we have lots of big ferrules and small ferrules, giant fork terminals. They were all wrong. I need the 5.5 here. Oh, these are ring terminals. Okay. Are these SV8? No, that's for 10 gauge. 5.5. Yes, forks. I need one of those. So we need an SV. SV is a fork. And then a 5.5, that means that 5.5 millimeter square fits in there, and a 5 size fork, so a M5 fork basically. And we also need one of these. And that will fit on the Raiden power supply there. Okay, I'll need to crimp these. Goes into the biggest hole. There. Have it poke through a little bit, and then let's squish it down. There we go. That's a fairly decent crimp. See, it's nicely squished onto the metal there, just poking out. That's good. So let's do that again. So I line up the tool so that it's just poking out a little bit. And then you try to get the wire in there. Have it poke out a little bit like that, and you crimp it down. Yeah, I have all sounds disabled there. I'll check out in a minute. Oh, the action. Oh, okay. What's this about? So we got a link for onderzetters in the Netherlands. I seem to be able to, I seem to need to find a Action store. Haven't been there in 10 years. And then they're very expensive. They're 63 cents a piece. Oh, but they're FSC certified cork. They're responsible cork instead of bio-waste cork. So that's good. Right. So now we have our little 2 crimped on connectors here. And these should fit directly on the Raiden, but I just cropped in all the views so you won't be able to see that anymore. Sorry. Let me get rid of this. It's always horrible when that lands on your desk. Makes me think of a few weeks back when I had lots of metal filings on my desk. Still finding them sometimes. Okay, so let's connect this to negative. And this to positive. So we're first going to measure just the 8 gauge cable. And we'll run it with 8 amps at 5 volt or 12 volt. Doesn't really matter. And then see how warm the cable gets. And I'll also see what voltage we end up with. And then we'll add the pigtails and see how it changes. Let me zoom that out a little bit. Untersetzer! Yeah. German is always a bit, you know. It's not a kind language. Where they say like French is like romantic. German is like, ugh! Okay, okay. So let's turn that right and the right and on. Oh, look at that image. It's slightly bothering me that it's there. Can I focus that just a little better? Let's no. There we go. That's nice and clear, isn't it? Okay, so let's set it to 5 volts. And it's currently set to max 4 amps. Let's set it to 10 amps max. Okay. And on the tester, we're not seeing any voltage. Oh, we're seeing 0.5. That's interesting. But the output isn't enabled yet. So let's turn it on. Oh, right. I skipped over this part. Let's turn the output on. Oh. It's still showing voltage? I thought it wouldn't. Because we didn't connect the sense wires. We only connected the load wires. So let's turn that off again. And we actually need a little bit of this pigtail wire here. Come on. And we're going to make a little bridge between these terminals, because otherwise we can't measure anything. Or we shouldn't be able to measure anything. So let's get that open completely. There. Strip off a good amount on this side. And a decent amount on this side. Twist that a little bit. Okay, then we take our negative cable and I'm just gonna wrap it around there so it makes, you know, fairly decent contact, we'll say. And I'm going to stick it back in that terminal and screw it down. Dutch is every language combined into some crap. What? What do you mean? Why do you treat me like that? Okay, and then we just take this side and it goes into the sense wire terminal. I mean, I like speaking English. That's pretty obvious, I think. But I don't think Dutch is crap. Moo says, I refuse to believe the Dutch language is real. It is. It is. It certainly exists. So, okay, decent amount. Decent amount. Okay. Twist it up. Nobody speaks bicycle? What? Wrap this around here. Kind of twist it. It's not long enough. Okay, let's do the other side. Make it a little bit longer. It just needs to contact because there's basically no current going over it, but that should do. That's not in nicely. Okay, hold on. So there's a 101 people here who are watching me bodge a wire in. Nice. Welcome everyone. This is the Quinder bot stream. Let's give it a little bit less or more insulation so that I can wrap it a little bit better. There, that's better. And then put it in here. That is a lot better. Starting a new project in KiCad. What are you going to make? Okay. And now we just need to add this little guy over here. Okay. So basically, we have the primary positive measurement terminal, or load terminal, bridged with a little wire to the measurement positive terminal, and the same for negative, the negative load, and the negative measurement. And now, if we hit power, we also actually see 5 volt or 4.99 coming out there, and we see 5 volt coming in, because before it couldn't really measure the voltage. You always need everything connected here. So let's, we're allowed to go up to 10 amps here. That's fine. Let's do 4 amps. Oh wow, we're already seeing a lot of voltage drop. But we don't actually know if we agree with that. No, go to DC. Oh, use remote. Okay, hold on. DC voltage. Let's see if we're also seeing that on the multimeter. Yes, we are. So even without pigtails, using this big bundle of wire I showed you before, we're already at 4.63 volts at the end of the cable. Because if we measure these terminals, yeah, the power supply is definitely outputting 5.0051, but then once it travels through the cable, I guess I can try and poke the cables directly and not the terminals. Oh, other way around. Hold on. Yeah, 4.63. So measuring on the terminals, yeah, it's about the same. So even just traveling through that 12 gauge cable with a 4 amp load, we see a 0.37 drop in voltage. And that's only 4 amps. So let's go to 8 amps. We now see 4.3 volts. Yeah, that's about right, 4.26. So the multimeter agrees with the measurement tool here. It's slightly off. They're calibrated differently. I'm inclined to believe the multimeter, even though what we saw before, a bit better than the testing device itself. But yeah, let's measure the terminals again. Make sure we're actually getting what we're asking. 5.006. That looks good to me. Okay, let's have that running a little bit. And are you sure about the wire length? No, I'm not. So while that is running and heating up, let me look up the listing or the AliExpress order, because it could actually be 10 meters. No, it's not one. That's 4 gauge. 6, 8, 16. I need to find the order I got this in. Oh, okay. So I had an order for. Let me just share this. Okay, need to make sure I don't share the wrong things. Okay, there. So I had an order for 12 gauge 5 meter in dual cable, black and white, or red and black, but I had a ×2. So this might actually be closer to 10 meters instead of 5 meters. And I might have used a part of it because it's wrapped in my own way with the cable tie or the Velcro, hook and loop, whatever. So we don't actually know the actual length of this. But it's probably closer to like 8 or 9 meters. And I don't really feel like measuring it. It doesn't really matter though. Because in the end, it only matters the resistance we see now and the resistance we see when we add the pigtails. Check with the voltage drop for 80 meters. Sure, let's do that. 8. Calculate. So we're supposed to have 0.66 volt drop. So 5 minus 0.66. That's 434. And we're about at 4.3. So it might actually just be 9 meters. Because then we get 4.26. Yeah. So it's about 8 or 9 meters of cable. Sounds about right. And it's cool. We can actually see the resistance here. We see a resistance of 0.5. Now I wonder if I can do a resistor measurement while there's a load on there. Or maybe it will explode. Oh, I have to exit remote mode. 2-wire resistance. We're just going to try it. We're going to try and see... good voltage drop calculator. Yeah, exactly. Let's put it on the negative terminal here. And then also on the negative wire here. I don't know about that measurement. Should I turn this around? Oh. We're getting 366 ohms. I don't think that's correct. You like the approximate today. Yeah. Okay. It's been running for 7 minutes or so. Let's get the measurement tool out. 2-wire resistance. Yeah. Because I don't have 4-wire connected. So 2-wire is correct. I know, but the probes aren't connected to anything. If I touch them together, you basically get 0 resistance. Well, I'm not touching them correctly, so, yeah. Okay, we have the thermal probe. Of course, I didn't make this long enough. Sure, let's do it like, I don't know. Let's measure it here. There's other stuff on the screen that's hot. So let's try and get that away and just measure the cable. Yeah, even with 8 amp load. So the little pigtails are warmer. How warm is that pigtail there? The pigtail is 30 degrees, but this cable here, it's barely warming up. 26 degrees. I don't know. There's not really much current going through there, but there is some. But it's just showing anything that's hotter. So it's 30 degrees on the pigtail wires. That's fine. Are you saying I might have hooked them up wrong? Yeah, they shouldn't warm up. I don't know. I don't think I hooked them up wrong. Maybe I did. Please add more load. Well, if there'd be 8 amp going through this cable, I'd expect them to be a little bit warmer, actually. Less isolation? You mean insulation? As in the outer shell is less thick? I guess so. I still think it's hooked up correctly, though. Because otherwise we'd see way more voltage drop, I think. I don't know. Well, that's what we're going to find out, aren't we? So yeah, currently, currently this wire is it's just about room temperature, and the pigtail is indeed heating up a little bit, but it's still 30 degrees. I can actually measure that. Let me just try and make sure. I need to find the correct device. Hold on. Okay. This is not the correct device. Nope. One moment, please. I need to find my clamps. Where did I put them? Interesting. Yeah. Right. One moment, please. That's odd. My clamp meter should be right here. But it isn't. But then, oh, I think it's here. Okay, found it. Ooh. No, I didn't get the resistance per meter. So, let's go to, I guess, 60 amp. Let's zero that. And let's see what's going through here. Interesting. We might have hooked this up wrong. But this will already have proven our theory also. Yeah. Seems like there might be 8 amps going through it. I can't measure this because... Okay, let's stop this test real quick. Let's turn this off. Let's just wire it up in reverse. Right? I might have understood that wrongly. And that could also explain part of the voltage drop. Exactly, Philip. This already kind of proves the point. That little pigtail wires are okay. So, let's move this one over here. See, I generally always use the fork style, so then it doesn't matter where I put it, because it's always correct. But in this case we can't, so... No, 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 no. As I said, I also have a second topic I kind of want to test. It's kind of like the same thing like last week. It's something I want to test, and maybe we can do that with you guys there. That was fast. We're like 1.5 hours in, but okay. Let's do the other side. Okay. And last wire.
I'm lost in old ways. I'm not afraid.
It doesn't count in actual stream content. Right. Okay. So we now have that hooked up the other way. Let's immediately hit it with 8 amps. Oh wait, we can't, because power supply is off. Power supply is now on. Well, we're seeing about the same voltage. That is actually expected. Wait for the thermal camera a little bit. But we should now see that the sense wires don't actually heat up.
They talk about another kind of work. Another kind of...
Oh, clamp them. Yeah, right. Sure. Let's zero this. So, clamping the negative side. Ooh. Yeah, now we're seeing 0.00. So, this is the correct way to hook it up. But that kind of already proves our point. 0.0, almost nothing. Oh, I unhooked up. Damn it. I knew that one wasn't incorrectly. Quinled Industries. There, that's a lot better. Okay, it just wasn't incorrectly. There, let's do it again. Yeah, so before we had it hooked up in reverse, so we had the sense wires. Currently, we see about, well, basically nothing going over the sense wires, which is what you'd expect. So we had it hooked up wrongly. Now we have it hooked up correctly. But as you can see, the voltage is basically the same. Oh, can't do it over here. Okay. And the multimeter sees about the same as the measurement tool, 4.25. Yeah, we're testing with 8 amps. So let's give it a little bit to warm up, but I don't think anything will happen. And then we'll add one of these pigtails to the end here, and after that to the beginning here, and see if that changes anything. So currently, with no pigtails connected, we're seeing 4.27 volts or 0.53 resistance. Can somebody... I'll write that down myself. Hold on. So we're seeing 8 amps, 4.272 volts, and 0.534 ohm resistance. Right, okay. Okay, well, we already measured how warm the cable got. It basically didn't get very warm. Now, what's interesting to note, people often ask me, like, do we really need 12 gauge or 10 gauge? Yes. Yes, you do. Because 8 amps isn't an unrealistic load for 5 volt LEDs and a middle injection. So if you have a 5 meter strip and another 5 meter strip and you inject the middle, you can draw 8 amps. So, yes, you need this thick of a cable to get there. That's the problem with 12 volt or 5 volt LEDs. Okay, let's quickly kill this. And let's just add the pigtail. See what happens. Well, 12 volt can also draw 8 amps, but then you can at least suffer a little bit more voltage drop. So let's get these into the clamps. Burn it onto the ground? Maybe not today. Although our second topic might. Out of spec? What do you mean? Oh yeah, this is already officially too much voltage drop because we recommend not dropping more than 10%. So, oh, this one's not long enough. So 0.5 volt. These are AliExpress Faco Wago. But as we just measured, in theory, the connection is fine. There. How do I want to do this? Let's disconnect this side. And then we need to twist these together. And stuff it inside of here. Let's twist these together. Okay, so basically we have exactly the same thing now, except that our cable goes into this Wago, and it comes out through this little thin cable here. This is a 20 gauge, this is a 12 gauge, and it goes into the correct terminals this time, and then we have the sense wires. So let's immediately hit it with 8 amps. Nope, can't. Have to turn on power supply. There. There. Boom. Oh, we do see a bit of a bigger drop. So let's get the thermal camera out, see what happens. We know the big cable is fine. Yeah, this little thin cable here, that's heating up. It's now at 35 degrees. Let's wait a little bit. It's about 35 degrees Celsius. Would magic smoke with some sparks be enough to end our strike? Okay, we'll do the second topic in a minute. Don't worry. Oh. This part is actually getting hot. You know what that means? Who can tell me why this part of the cable here is getting hot? Well, the rest of the cable is basically fine. It's 29, 30 degrees. But this here is now at 40 degrees. Oh, okay. Jan got it right immediately. It's a bad connection. Exactly. So this likely isn't... I was going to say isn't in far enough. But it should be. So let's try that again. That might also be why we saw more voltage drop than I was actually expecting. Okay, power supply on. Oh, okay. Didn't turn this off yet. Okay, well, we see a higher voltage now, because before we saw about 4.0, and now we're seeing 4.15. So, this connection was causing voltage drop. Because it's a fake Wago? No, I don't think that's the issue. Okay, right now this connection here is... Okay, I need to get my hand out of the way. It's about 31 degrees. But the Wago itself is also about 31 degrees, because this short cable will heat up. That is now about 35 degrees. But as you can see here, we have a little bit of extra voltage drop, but not that much. Want to bet? No. Why? I don't actually own any non-fake Wagos, so yeah. But let's write that down and continue with the test. Where's my notepad? Where is my notepad? Here. So now one pigtail add tester. Oh, well, one pigtail and Wago at tester. We see 4.152 volt with 0.508 ohm resistance. So although it does voltage drop a little bit, and it's likely more my bad connection here than this little cable, if I'd solder that, it might actually be better. Let's have a quick look again. Okay, so the 12 gauge is staying around 30 degrees. That's probably correct, because if we look at the rest of the roll, it's 27, 28, 30, 32. Yeah, so that's about the same. So this connection is now fixed. It's not heating up more than the cable itself is. But the pigtails are still warm. They're 35, 36. Which is fine, it's okay. Okay, so that adding one pigtail did drop voltage a little bit. Could also be possibly from the connection a little bit. But let's add a second pigtail and see what happens. Where did I put my second pigtail? No. Oh, here. Let's see if I can do that with these spades on there. I don't think so. Oh. It's stuck. Okay. I don't think I can make a connection like this. No, that's not going in far enough, so I'll have to snip it off. Oh no! Okay, those are gone. And then I'll have to strip these back. And the Wagos like them really long. There's probably going to be some out there who are going to say, you shouldn't twist them. Well, it's hard to get them in otherwise. Okay, that's, I think, a good connection. I want to get every hair. There. Okay. And let's remove this one. I can always crimp on new ones, I know, but you can measure the voltage over the pigtail? What do you mean? Okay, now over here, I kind of need to just wrap it around the terminal and then close it shut. I don't think they have a little hole in there. Oh, my tester is complaining. Okay, sorry. Hold on. There. So I'm just going to wrap it around and then close the terminal. I don't really want to move the camera right now. I think that one is okay. Let's do the other one. Okay, that's wired in. For these, it says on there that it's 32 amps. And it'll certainly drop a bit of voltage there, but these are 32 amps and they support 0.08 to 2.5 to 4 millimeter. 4 is probably without ferrules. So we're exceeding that a little bit, but you know. Right, let's enable the power. Okay, without load, we're still seeing 5 point whatever we saw before. Yeah, but these are okay. I mean, they don't heat up more than the cable does. So if there be a lot of resistance inside of the Wago, we'd see it heat up. Anyway, let's go. Okay. Let's make sure we agree with that measurement here. Yep, 4.02 something. That's about the same as we see on the display there. Can't really measure here, but I might be able to measure here. .413. So we're dropping a little bit of voltage on that pigtail again, but that's expected. Thank you, Maiko. So now we have two Wagos on there, or two Wagos and two little pigtails. Let's see what we have. Two pigtail and Wago at tester and source. We see 4.043 volt and 0.505 ohm resistance on the tester. So we went from 4.72 volts to 4.032 volts, right? So we did drop about 0.25 volt because of the pigtails and the extra connections. It's not just the pigtails. It's also any any connection adds a bit of resistance, so we'll add drop. Probably if we soldered it, we could minimize that drop, but even with a Wago, it's not that much. Maybe Johnny did some calculations there. No. We'll take a look at it at something else real quick after this, and there will probably be smoke. So the pigtail at the power supply side is actually 41, 38, 39. It's about 39 degrees, 42, 41. So it's slightly hotter than over here, but that's logical because we already have voltage drop on this long cable here. So the voltage here is lower than the voltage at the power supply side, and running the same amps, you thus get more watts that are being transferred into heat. So that's why the pigtail on the power supply side is warmer than the pigtail on the load side, because the resistance on the cable so far has already removed some energy, thus the voltage is lower. Do one cable make good fuses? I don't know, man. Can you measure the positive wire in the Wago to the positive terminal on the load tester? Yeah, but only without a load, because I just tried that. So let's set it to resistance mode. And positive terminal here. Positive terminal here. Yeah, it says 0.16. Can I leave it like that? Okay, it'll change a little bit because there's no pressure on there. But if I now enable the load... oh, the power supply is off. Okay, let's turn the power supply on. Yeah, I get a very high resistance there, which doesn't really make sense. So I don't think we can measure it that way. These load testers are on my tools and equipment page on Quinled.info, the DL24, but it's in the list of testing equipment. You can find it on there, Danny. I have 5 of these. I really like them. So, conclusion time then. Adding little pigtails, especially with Wagos, does cause some more voltage drop, but if this entire length of 8 to 9 meters would have been 20 gauge, we would have seen 2 volts or something like that instead of 4 now. So adding the little pigtails on the power supply side and or on the LED side will cause a little bit of voltage drop, but not that much. And normally 8 amps is a lot. You basically can't get that into an LED strip unless it's a middle injection, and then generally you have 2 pigtails to deal with instead of just 1, and that will already lower the voltage drop there. So using a little pigtail wire to solder to the LED strip and then connect that to a bigger wire to run the full length of that you need to run, and then maybe stepping down to a pigtail on that side again too, is perfectly fine. Yes, it creates a little bit of voltage drop, but not as much as the whole cable being the thin cable size. And I used 20 gauge here. Normally I solder 18 gauge to my LED strips, and that's already a lot thicker than this 20 gauge. So that would cause less drop, etc., etc. So yeah, that is the conclusion. Using pigtails will cause a little bit of extra voltage drop, but you can't solder this 12 gauge to an LED strip anyway, so you'll have to. And that's it. And we're testing here with 8 amps to exaggerate the effect. Normally you can only get 4 amps into an edge injection. but you can get about 8 amps into a middle, but then if it's a middle, you have 2 strips there, so maybe make 2 pigtails and solder 1 to each. Hey. Cool. Sure, and using shorter wires helps, and then maybe soldering them instead of a Wago. You can minimize it there, that's no problem. But this is just to demonstrate the effect of adding 1 or 2 pigtails to your wire. You need the thick copper for the distance. Having some thinner copper for a short wire is fine. And we're really stressing this 20 gauge with 8 amps. That's a lot for 20 gauge. So, but that's just to exaggerate the effect. Well, it just won't take it in, Emil. A 5 meter strip will take in 13 amps, but you'll need at least 3 injection points for that. So yeah. Right, so that is the first test I wanted to do today. And something I kind of want to do for myself is in the most recent Quinbox I recorded, which you haven't seen yet, I got some boost converters. And this boost converter's specifications has me slightly confused, because let me try and find it. I have 2. And I have a different model also. I have lots of models. There. So I got some new types I want to test, or specifically the chips on there. And I was thought like, okay, instead of designing it myself, let's just test a pre-made board with this XL1609 on there. And if I look in the datasheet, let's take a quick look. One moment, please. Come on. There. So if we look in the data sheet, we see this is a 5 volt to 40 volt in. Okay, that's cool. And it has a maximum 5 amp switching current. Okay, cool. It has a high efficiency up to 94%. Nice. That's all good. But then in other parts it says that it can only do like 15 watts or something like that. And I'm like, what? Why? I'm not sure I can find it in the datasheet. I know the website says it. Yeah, all the graphs also only go to like 1400 milliamp, 1800 milliamp. Why? I want to switch more. Again, 1.3 amp. So I'm like, okay, so can it do 5 amp? Can it not do 5 amp? What's going on? I mean, I wanted to do 5 amp. So what we're going to test today Sure, well, I just want to evaluate the chip. But so what we're going to test today is we're going to input, this side is in, okay, 20 volt, and we're going to output 24 volt to the load tester here, and then we're going to see how much current we can draw before it explodes. Yeah, I don't know. We'll see. We're killing a chip. Yeah, exactly. So let's reuse that little pigtail we just made. That's fine. Do I want to put ferrules on there? Nah, I'm not too bothered today. I'm just going to fold this over and twist this guy and fold it over a little bit. There. Maybe cool it to sub-zero, yeah. Okay, so out, negative and positive. These are hard terminals to use. Damn. Need to modify these terminals a little bit. Okay, let's try that again. Positive. There. Positive went in. Let's screw that down. And let's redo this guy. There. Maybe there, Dradstal. Maybe. Okay, so we have positive out and negative out. And now we just need it in. But I'll need a little bit longer cable. I guess we can use some more of this 20 gauge, huh? Do I want to? No, actually don't want to. Maybe I can use this cable. I have to remove this guy. I'm not going to talk about what that is for. No, wait. These ferrules will never fit in there. Yeah. Don't think that'll work. Okay, that's never gonna fit. Never mind. Cannot use this cable. We need pigtails, yeah. Yeah, but these won't fit in the Wagos. I don't think they're going in deep enough. See? That's not gonna work. Ferrules in Wagos generally not great. Solder them to the underside of the PCB. Yeah, don't worry. We don't need that many amps. We're just going to use our 20 gauge here. And we're going to make a new cable. It's, I don't know, something like that. That's fine. Let's try and screw that into our power supply. I'll try and show you this time. I'm just hooking it up jank style. There. So I made a little loop like that, and I'm just putting it over like that. I'm gently tightening this. Try not to get the insulation in there. No. Whatever. It's kind of janky, but it works. Better to put 4 terminals on there, but as I said, this is a very, very temporary cable, so. Come on.
I'll tell you the truth.
that should make plenty of contact for what we're going to do. There we go. If there's no smoke, then the strike will continue. Aww. Well, we're likely going to cook it, so I'm thinking there's going to be smoke. Can't promise smoke, though. Yeah, exactly, Maiko. Okay, let's widen up these terminals a little bit. There we go. In negative and in positive. Yeah, let's do it one at a time. Negative is incorrectly.
Alright. I'll tell you the truth.
That's not pretty at all. Come on. This is why I use ferrules. I guess I should have just done so here too, but there we go. I always hide the smoke. Okay, now let's get a non-flammable surface, like the cork we just talked about. And we have the tester there. Okay, let's set this to voltage. Okay. And we're going to say 20 volts. And we can set it to 10 amps, that's fine. Don't forget your glasses. Thank you very much there, Mr. Blue. IKEA crap cork, yes, but it shouldn't catch fire. If it also catches fire, it's really bad cork. Right, so we have the in negative, in positive. That looks correct here. That looks correct here. We have the out negative and the out positive. That all looks correct. We have our pigtail wires, etc. Didn't change those. Let's set it to 1 amp, but we're not going to enable it yet. Let's turn the power on. Wow, that's a bright LED on there. Holy moly. And I'd want 24 volts. So let's... No, not increase it. Give a little bit there. 24 volts. So we have 19.98 volts going out and 24 volts coming into the tester. And I guess we can verify that real quick. 2402. Yeah, looks good. Okay. Right. Let's give it 1 amp load. Right? That's good. Voltage remains the same, so it doesn't sag. And it's drawing 25 watt, and we're getting 24 watt. So we're losing about a watt somewhere. That's probably in heat. Let's fire up the thermal camera there. Oh yeah. Okay. Let's move that a little bit. Wow, that's stupid. Okay. You know what's warmest? Can anyone tell me what is warmest on this board? Can anyone tell me what is the warmest component on this board? Exactly, it's the LED. Which idiot designed this thing? Why is the LED the warmest thing on this board? What? I already mentioned that it was way too bright. Why? Why? Jesus. If you're able to design a PCB like this, and then you don't think, let's put a high value resistor on that LED there. No! No, just burn it up! Burn it up! That's so stupid. Okay. So the other thing there is a diode, and that is currently 62 degrees. Okay. What kind of diode is that? Can I see that against the power of that giant LED? It's an SS34, so it's rated up to 30 volts and 4 amps. Okay. No. 3 amps and 40 volts. Yes. Okay. We're losing a watt somewhere. Yeah, exactly. Why? Why is it that stupid? I mean, it's not running uber hot, but it's still stupid that it's the warmest. 68 degrees. So bad. Okay, the backside is about 44, 43. Yeah, I could desolder it, but... Right, so let's go to 2 amps. See what happens. Oh, now the diode's certainly getting the warmest. The diode is now 90 degrees. And I'll try and refocus that. There. 95 degrees. So we're outputting 48 watts. Oh, you can't see that, can you? There. 48 watts. We're still getting a steady 12 volt, or 24 volt, that's good. And we're inputting 52 watts almost, and we're only getting 48 watts out of it. So somewhere it's getting lost. But yeah, the diode is certainly the warmest. Go to 10 amp. No, we'll move it up slowly. Stick a heatsink on the LED. Yeah. What? Well, it seems to be able to do 2 amps. It gets about 100 degrees. That's not great. Bottom side is heating up a bit too. It's not too bad. Yeah, chip is hot. Inductor is fine. So, if this diode is already 98 degrees, what would happen if we went to 3 amps? Oh, it's still outputting 24 volt. Oh, uh-oh. Oh, it's 126 degrees. 127. 130 degrees. But the chip is fine. The regulator chip is only like 65 degrees. That's not chilly, but it's not like very hot either. If you get a much better diode, it will desolder itself. No, it's probably hassle, so it'll need 300 degrees to desolder. Is this cap warm or is that reflection? No, it's warm. It's warm. Okay, and the inductor is starting to warm up. Yeah? And the LED still... Oh, look at that. Look at that. We're starting to drop voltage. Cables aren't really warm because we're only doing 4 amps input. Yeah, it's not holding. It's not holding. See that? Yeah, the diode's 140 degrees. The chip is 80 degrees now. Okay, let's give it one more amp. Oh, 21 volts. Yeah, we're at 163, 164, 166. Let me, no. Something where we can read the temperature. There, now we can read the temperature. 169. But voltage is slowly declining, as you can see. We're now only at 21 volts output. But it is almost doing... It's doing 84 watts. Yeah, exactly. The thing I see in this design... Oh, it says above 170. Yeah. Still, it's pretty decent. Let's see what the bottom of the board's doing. Okay, so the area where the chip is 94 degrees. But it is doing almost 4 amps. No, it is doing 4 amps. It just can't reach the right voltage anymore. Okay, let's go to 5. Okay, we're inputting 107 watts, and the output is 97 watts. That's not great. So let's see, the chip is 87, 88, and the inductor is 90, 95, 98. Oh, the inductor is almost 100 degrees now. It's probably not rated for this kind of load. So now we're basically getting 19.98 volt in and 19.45 volt out. But there's 0.37 amps getting lost somewhere, or 97 watts versus 107. But if that diode would have been beefier, like a 6 or an 8 amp diode, and maybe a bigger inductor there that can handle more current, the chip is only 92 degrees. Well, only, it's not cold. But it's also heating up from that 170 degree component over there. Let's see in the back. Yeah, okay, the chip is getting hot itself. The bottom side of the chip is almost 100 degrees. See, but that's why I was so confused. This chip should be able to do 100 watts. And it's almost doing that. You would then waste a lot of power? Why would you waste a lot of power? We're currently wasting a lot of power in heat. Yeah, more efficient, less resistance diode, sure. No smells yet. No smells yet. It's not burning yet. I mean, it's certainly warm. I don't know, 6 amps? Oh, wow. It's doing that? Okay, I'm starting to smell something. Burning protection. What? Do not direct the infrared camera at high temperature radiation sources. I've never seen that before. Okay, it's starting to smell. Oh! No, I thought the inductor might be melting. Okay, yeah. Something's starting to smell. It's not the wires. Oh, yeah. Okay, let's go for 8 amps. See what happens. Oh, man, it stinks. I think it's actually the PCB itself might be boiling. Ugh. There's no smoke, but there's stink. I'll try and zoom in more. That's all she's got. Man. Oh, there's smoke. The inductor. No, there's smoke here. Can you see it? I think it's the inductor smoking. Okay, let's go. 9 amps. How much? 162 watts. Man, it stinks. But the chip isn't stopping. It's not stopping. It's still outputting 162 watts to the tester. It's 18 volts while 20 volts are going in. The LED is the only... Yeah, I don't think a fume extractor will help when your whole room is smelling like this. I just try to stay away a little bit. And how is that diode not melting through the board? It's not blowing. Okay, but let's see what happens. I know that's boring. Let's go back to 1 amp. See if it cools down and then goes back to 24 volt. Yeah, I actually like XL semi chips, this is one of them. They are good quality. The voltage seems to be slowly rising. You can see the voltage over here. Yeah, 19.6. Throw a screwdriver in there. Are the solder joints melting? No, it's probably Hassel solder, so... But I think this is like a 1 or 2 amp inductor max. Okay, let's turn the tester off for a little bit. Oh, boom! 23.6. Let's blow on it. Oh wow, watch me blow on it. The more I blow, the more volts we get. Can I blow it to 24 volts? Oh, this is just some residue. It's plastic. I don't see a partly bald head. I know, I know. Okay, let's see how warm it is. Infinite power. Yeah, as long as I can produce wind. Okay, let's try and get this better. There. Oh, now you can see the thermal. Okay. Well, the LED is still 78 degrees. Oh, the inductor is having a hard time cooling off. 59. The chip is 58-ish. 59. Why is the LED 80 degrees? That's just so stupid. Okay, let's see what happens if we hit it with 1 amp load. Do you think voltage will sag? Oh yeah, okay. This one might be done. It might be cooked. Okay, I have a second one. And there's a different input voltage that I want to test. Yeah, that's actually not bad. I mean, it should have thermally shut down at some point. It didn't. So we have a second one. And I want to see if it can do 24 volt output with 12 volt input. These were a few bucks, I think. So, in minus and in positive. At this rate, we'll be striking forever, yeah. Sorry, I tried. No, these are boosting boards only. I kind of expected them to fry. Now I think it's dead. It's not regulating correctly anymore, but there wasn't a catastrophic failure either. And as I said, I use some Exile Semi chips for other designs I have, and I generally actually like them. Right, so VSET 12. Let's see, minus, plus, minus, plus, yep, okay. Power. Okay, so 12 volt in gives 27, whoa, I don't want 27 volt. Okay, 24 volt out. Let's hit it with 1 amp. Oh, what? Power goes up. Voltage goes up. Why? Are these genuine ones? I'm not completely sure. Let's regulate that down a little bit. There. Okay, that's fine. Okay, let's hit it with 2 amps. Seems it can comfortably... Oh, no, it can't do that. Oh, no. Oh, wow. Okay, why not? So it can do 12 volt in 24 volt out. But if I say do 2 amps, it drops to 20 volt. So it can't boost from 12 volt to 24 volt. It can only reach 20 or 19.4. Interesting. That's not great. Okay, let me mark this one real quick to remember that this is the one we kind of blew up. There. And for the people who are hanging around, let's turn this off. We're going to try one more other different type. Yeah, so it's able to boost 20 to 24 volt. And it can boost 12 to 24 volt, but not with a higher load than 1 amp. Interesting. Cool, okay. So, yeah, the diode's hot again. Okay. So we have 2 different types here. This is the XHM411, but I selected them based on the chip that's on there. There's a lot beefier diodes on here. And then there's this one. And I'm interested in this one, actually, the most. So we're going to do that one. Same sucky terminals. Yeah, this uses a different chip. And this one should be able to do about 100 watts. Okay, let's hook it up first. And that is the last thing we're going to do today. Yeah, these are a bit more expensive. Not that the other one's bad quality, it's just limited in what it can do, I guess. Jesus. Get in there. Okay. Oh, wait. That's wrong. That's wrong. Whew. Almost did it wrong. I guess it would have been a good test for the reverse polarity protection on the output. Thanks, Dave. I just caught it in time, I think. It also has to do with price there, Tokala, because larger terminals also cost a lot more. So, okay, in positive. Man, should have used ferrules. I get that, Takala. That's why on the Dig Octa series, I opted to go with much more expensive terminals. Some are like 5 or 6 times the cost. But they're a lot easier to work with and much bigger and things like that. Actually, these inspired me. These are the same kind of type. I used slightly different ones on the Power 7. And they take 10 gauge without ferrule or 12 gauge with ferrule, and they're very snug and like those a lot. Right, so we have in positive, yes, in negative, yes, and then we have, yeah, okay, that's in there. we have out negative and out positive. Okay. Don't click the mouse. There. Okay. Well, we're doing 12 volt again. Wait, stop. What's going on? No! I wired it up in reverse again. Oh, stupid me. We quickly saw some draw there, didn't we? Yeah, I was checking, but I wasn't paying attention. Oh. Well, let's see if it died. Sorry, Philip, no smoke. You know what? I'm done. I'm actually smelling something slightly burnt. So I might have killed it. I'm done with this shit. Yeah, I know, Worm. Normally I always do, but then I want to be too quick during the live stream, and then I don't. But it's stupid. I don't have the right size ferrule for these. Huh. Oh well. You need more caffeine, yeah, probably. Well, let's do the little trick where we actually squish the ferrules a little bit. And now they'll fit with ease. There. I don't know, maybe it's already blown. We'll see. Okay, 12 volt. Seems still to be working still. So, it's saying 12, but... Oh, okay, so it has an in and an out LED that aren't insanely bright. That's a good start. Can I hold it? What does that do? What? I don't know. But there's a pot here, because we're getting 13.7 out. I want 24. Okay. I know I should put ferrules on there, but you know, I'm the ferrule guy. So this is, oh wait, maybe this is like deviation or something. Yeah, okay, so you can change the offset of the screen. Okay. Huh. Okay, let's give it 1 amp. Beam. Alright. That's fine. Sure, we get a bit of voltage drop. That's fine. Okay, 2 amps. Okay. So far, so good. But then again... No, wait. What am I smelling? Wait. There's 4 amps going in? 53 watts? How am I... Oh, no. That's correct. We're inputting 12 volt, 4.43, so 53 watts. And we're outputting 24 volt, 2 amps, so 47 watts. So we're losing 5 watts. Yeah, and these guys were stupid again. Because this inductor is just too small. See that? That's 51 degrees. That's not bad. 54. Oh, let's go to 3 amps. It seems to be doing okay. Nice. Oh, is the voltage dropping? Yeah, I think so. Yeah, the voltage is sagging. But for science, let's go to 2.2. Because that's what I realistically needed to do. Sure, that seems to be working fine. What? Oh, it's also saying itself that its output is 23.8. I guess we could tune that a little bit. Yeah, 24 volt. Yes, the IR cam is in there. It's a Doji 98 Pro or something like that. So it's a Doji. Yeah. It's in some of the Quinboxed, and I think in the last live streams, I think I also included, I'm not sure. The LED isn't as impressive as on the first boost converter, that is for sure. Well, this one seems pretty well behaved. Let's check the back. Yeah, this one's fine. 50 degrees on the back. Yeah, that's fine. Yeah, Chinese are funny with naming things. Do you know what the brand name for my tester is? Let's see if it's on the back too. No. It's on the fan. Hold on. Let me have the fan spin down. Do you know what the brand name for this tester is? The brand name for this tester is A Torch. You've got to be kidding me if that's accidental. It's not possible that you call a company that produces a electronic load A Torch. I mean, come on. So, it's either a very funny Chinese guy, or he has no clue whatsoever about English. Anyway, let's go to 20 volts. Okay. And, oh, it's outputting 20 volts too, but I want 24 volts. Oh, no? Why not? Why? Nothing is happening. Can I go lower? No. Oh, it's on in. Maybe I should be on out? No? What? Did it break? What broke? Can't it handle 20 volt in? 12 volt in. Okay, now it's giving me 25 volt out. Yeah, now I can change it again. What? Yeah, see, now I can change it. Okay. So, VSet, let's do it like that. 24, 24, 24, 24. Yeah, now it's working. So we're at 19, yeah, 20 volt out. Yeah. Huh? No, okay. Let's set it to 2 amp. Oh, let's set it to... I wanted to do 4 amp, so let's set it to 4 amp. Oh, something is 87 degrees down here. Probably beneath the heatsink. 90. The back is okay. Seems to be stable. Voltage output is, okay. Should put... What? Philip gets to pick a name? What? Well, this actually seems pretty well behaved. We're sending 20 volts in, 5.13 amps, and we're getting 4 amps at 24 volt out. Pretty steadily. Could be worse. Wait, so Philip goes on strike and he comes back as the CEO? Yeah, that's true. Quinnergy was suggested by the mods. I'm not sure who of you exactly again, but for sure. It's not getting warmer. That's always a good sign. Nope, staying the same temperature. Yeah, that's good. something down here is 88, 89 degrees, but it's not increasing in temperature, so yeah. Something over here is about 68, 69, 70. Okay, that warms the heatsink. Yeah, heatsink is warming up. It's not hot. Yeah, and there's probably some losses in these cables too, so it's not too bad. Okay, interesting. I'm going to drink a Coke with you guys, and then that's it for today. We've already been going 2 hours and 54 minutes, so... The bars are on strike? What? Cherry Coke it is. I don't know if Draadstal's still here, but the Cherry Coke came out. Where is the secret? Oh. Well, remember when I said I was testing something over there? It's still testing. It'll be so for the next few days. It's fine. Recently we've had a flurry of ESP32 boards failing for unexplained reasons. And those reasons are still unexplained. Next week I should be getting 8 or so failed ESP32s in so that I can analyze those. But I was already planning on making a revision of the ESP32 board this year. And, well, I just built my first prototype of that. And this is it. Kind of looks the same, but it kind of looks different. Right, so this is the current design. And in theory, there's nothing wrong with the current design. We've been using that for years. Just suddenly it started failing. But one of the things I've changed is the LDO, which is this one. Okay, let me show you in detail. I guess I can try and hide the details, but you know. There. Now it's still in development, it's not done yet. But so the LDO on the first one was this guy over here, and I've changed that to a much bigger one that's also used on the Dig2Go and the Dig Octa over here. So that can sink a lot more heat, and hopefully is more stable in that sense. It still has a PTC and reverse a dual connection diode, USB, ESD protection. But it has a different auto programming circuit chip. So first it was this guy over here with all these resistors. That's been replaced with this guy with also some resistors, but okay. The giant serial chip over here has been replaced by this guy. It's also a CH340, but fat LDO. Yeah, exactly. But it's a much smaller form factor, which still supports the auto programming. I changed the capacitor networks and stuff like that around, and other than that, it's basically still an ESP32 board. We still have our boot button here, and you know, but it's a little bit updated design I'm playing with. It still needs some optimization. I want to change a few things. It has an added feature. If you can see over here, it says IO2 LED. So that's a LED I was able to squeeze on there. You can turn on and off with GPIO2. Just as a fun feature on there. I thought about maybe integrating a temperature sensor or something other than that. But these are meant to be bare ESP32 boards. And anything I add adds cost, which then everyone using the board would have to pay for. And if it's a feature no one's going to use, well, that's wasted cost. That's why I basically don't add PUE to my boards and either stuff like that. But a little LED and a resistor, those 2 cents, I can get behind that. So yeah, it's a slightly reimagined design. It's improved in some ways. It's the same in other ways. And well, what's been running here is the Ethernet version on a DIG quad, because in the end it'll be put mostly on DIG quads and DIG Unos and things like that. And let's see if it's still up. Hope so. Let's change the effect. Yeah, we can change the color palette. There we go. Oh, you can't really see it, can you? Face there. Let's go to yeah. So that's been working great. This has now had an uptime of 20 hours and 51 minutes. So far, so good. So I still need to do more analysis on the failed ESP32 boards. I think it's a combination of maybe the LDO not being great in the latest batches we've received, and actually the W room module itself, so this big module from Espressive, dying on me. Now, the W room module dying on me, I can't really help that unless maybe the LDO, for instance, isn't performing its job correctly and it's killing it. But I need more analysis for that, and I'm hoping to do that next week or the week after that. But I had already been working on a new and improved design because I wanted to change some things. Yeah. So that one running over there is the same one, but then with the Ethernet hat on there. Yeah, maybe it got too much voltage that the LDO didn't regulate it correctly. And I know there's been a few where there is a short circuit that triggers the PTC, and or there's no LED on the board anymore. And that all kind of points towards the LDO. But I'm hoping to be able to say that for certain with the ones I receive soon. And then I know if what I changed in this design, so with the different LDO and things like that, is a good step forward or not. But one of the things we've seen is that we see it with these ESP32 boards, but we haven't had a single dig2go or dig octa fail in the same way. So, yeah, it has to be something with the components then, or just unlucky with the ESP32s. It's a bit confusing still. But yeah, working on that, and yeah. Will it be more repairable if overvolted by accident? Well, the first thing you'll kill, it'll probably still be the same. So this USB ESD chip gets 5 volt, and that'll be the first one to die. Then it's likely the LDO. But in my testing, I blew up 10 of these intentionally. It was always first the ESD chip to die, and then if I remove that, it would work again. I just couldn't program it anymore, but it would still work. And then the LDO would die at like 7 or 8 volt. This one is a bit more robust, but yeah, it's still a 5 volt or 3.3 volt LDO with not an unlimited input voltage. But yeah. No, the CH is fed with 3.3 volt. So that wouldn't die unless the regulator put through it too much. We wanted blow up intentionally live stream. Maybe at some point, but then I need to build a whole lot of boards and blow them up. So that's a lot of time. So I'm still not entirely sure what died on the customer boards. And to give you a perspective, we're still below 1% or even that, well below that, of boards that died. But it's still too much because it's defeating our testing methodology. We test every and each board. They come pre-flashed. We can't flash them if they don't work. So they worked. And that's what we see a lot from customers. They work for an hour, for a day, and then they die. Yeah, we can't test every module for a day. So it's very confusing what's going on. But the only thing we have to go on is that the dig2go and the Dick Octa haven't shown the same issue. So I already wanted to change the LDO, so I thought, okay, let's change some other stuff around too. And hopefully that has already fixed it. But more analysis is needed. Wat? Quint en de 100 klapper? 1000 klapper? Huh? As your new CEO, Philip is up for building 10 or 20 blow-up boards. Okay, sure. What? You're going to do the manual labor for that? Well, you'll have to source the components too. You'll be out a few $100. Well, okay, not a few hundred. Yeah, well, with the ESPs on there, yeah, that's going to be pricey.
They talk about another kind of work.
Oh, later, Dave. Thanks for hanging out.
What are you afraid of?
So, that was a lot of testing, wasn't it? It was fun, though. It's stuff I wanted to test, well, I kind of wanted to have a live stream I could point to for people who's like, can I attach a small cable to a thick cable? Yeah, you can do that. That's no problem. And I wanted to test those DC-DC converters anyway. So, yeah. People smoke? What? Well, I inhaled some molten inductor or something. So that will be good for me. If I get lung cancer like in a few years, you'll know why. It's all the smoking live streams. You said you needed iron? What? You'll do a donation drive if I get cancer. That's very kind. I hope I don't get cancer. Cancer's horrible. Oh, man. Okay. I think that is enough for today. That's been 3 hours at least. So, thank you all for hanging out. It was fun. We did a lot of stuff. We got some good tests in. We tested some boost converters and some buck boost converters. And we tried to melt some cables. It was good. Thanks for hanging out. Bye-bye.